We're going to find several derivatives using the chain rule. Let's start by finding derivatives of the following functions. If we have square root of 2x plus 5, the inside function is the 2x plus 5, and the outside function is the square root. The chain rule says we can take the derivative of the inside and multiply it by the derivative of the outside function. The derivative of 2x plus 5 is 2, whereas, let's see, square root of u, that's the same thing as u to the 1/2, so we get a 1/2 u to the negative 1/2. And if we move that u to the negative 1/2 to the bottom, we have 1/2 u to the 1/2. Again, the chain rule says we multiply these derivatives together. We can actually cancel those 2's out, and so I'm left with 1/u to the 1/2. Finally, I don't want my final answer to have u's. I need x's in my final answer. So I'm going to replace that u with a 2x plus 5. In addition, we can change that 1/2 power back to a square root, and I'm going to write my answer as 1/square root of 2x plus 5. Now for the second example, we're going to have to use the product rule. The x to the third is being multiplied by 4x minus 7 to the fifth. And we can't actually do that multiplication without expanding the 4x minus 7 to the fifth, which would take quite a long time. So instead, we're going to use the product rule. The first thing is the x to the third. The v, the second thing, is the 4x minus 7 to the fifth. My u prime would be 3x squared. And the chain rule comes into play when we find the v prime. This time, I tried to do the chain rule in my head without writing out the u's and the y's. And I think it's really helpful in some cases to be able to do it in your head, especially when you're combining a chain rule with a product rule. It can get kind of complicated. So what I did is I brought down the 5. We have something to the 5th power. So bring down the 5, something to the 4th power, and then the chain rule part is multiplying by the 4 because that's the derivative of the inside. Product rule says we take u prime times v plus v prime times u, and I did take the time to multiply the 5 and the 4 in my v prime. That's where the 20 came from. 5 times 4 is 20, so v prime times u. In some cases, we'll be able to leave our answer like this, but quite often it's going to be helpful to take this a little further. And what I mean by that is this expression can actually be factored. We have x's in both terms. In fact, an x squared can be taken out of both terms. And we also have that 4x minus 7 in both terms. The smallest exponent is a 4. So my GCF is x squared, 4x minus 7 to the 4th. If I pull that out front, x squared, 4x minus 7 to the 4th, then in the first term, we still have the 3, and we're going to have one of those 4x minus 7's left. Whereas in the second term, we still have the 20. We took out all 4 of the 4x minus 7's, and we still have one of the x's left. Finally, I can simplify what's inside those brackets by distributing the 3. That's how I got the 12x minus 21. And then we can combine like terms. 12 plus 20 gives me that 32. So there's my final answer in factored form. Now let's do an application. $200 is deposited into an account with an interest rate of R% per year, compounded daily. After 5 years, the balance of the account is given by the function. Find the rate of change of A with respect to R for an interest rate of 8%. That rate of change is asking us to find the derivative, A prime. Rate of change means find the derivative. We want to find the derivative when the interest rate, or when R, is 8. I'm going to have to use the chain rule on this one. The inside function, the thing inside the parentheses, is the 1 plus R over 36,500. That makes the outside function 200 u to the 1825. My u prime is 1 over 36,500. If that's not clear to you, it might be helpful to rewrite your u as 1 plus 1 over 36,500 times r. That's the same thing as dividing by 36,500. And then you can see that that number in front of the r is the derivative. My y prime, I took the 1825 and I multiplied it by 200. That's how I got the 365,000. And then u to the 1824, I minus 1 from the exponent. The chain rule says we can take these two derivatives and multiply them together. If we take that 1 over 36,500 and multiply it by the 365,000, we're left with a 10. And then the u to the 1824, I replace that u with the 1 plus r over 36,500. Finally, we actually want to find what is the derivative when r is 8. So to finish, I'm going to plug in 8 for r and then put all of this into my calculator. I got a number that was just a little bit under 15, 14.91. This number is giving me a rate of change. Since A is the amount of money in the account in dollars, and R is the percentage, this gives me how many dollars my account will increase by if I increase the interest rate. So the amount of money in the account will go up by about $15 per percent increase in interest rate.